Okay, we're on to our next presenter now. We have Lou from Gravitee, who will be talking about why streaming and API management go hand in hand, which is something that I've been trying to talk about for a long time. So I'm very interested in what the solution is here. Hi, Lou.
Hello. Thank you very much, Alan, for the introduction. Yes, so good morning, good afternoon, good evening, wherever you're joining us today. So let's get straight into it. So there has been a big upward trend with event-driven architectures. So let's pick Gartner. Gartner made a prediction in 2018 that by 2022, so this year, they're expecting to see event notifications forming part of over 60% of new digital business solutions. Over 50% of business organizations will be participating in event-driven digital business ecosystems. 50% of organizations managing APIs will be incorporating some kind of mediation when it comes to event notification into their operations. So this was made in 2018. And despite how good Gartner are at making predictions, I don't think they could have seen this one coming up. So obviously, the predictions that were made in 2018 will have been fundamentally impacted with what we've been seeing over the past 2 years. And it would not be surprising to see that actually whatever the adoption rates were for bringing on board event-driven architectures within an organization have massively sped up just due to the new ways of working. Okay, so let's take a step back and unpack this a little bit. What do we think is driving this trend? What's behind it? And there's going to be many factors, but let's look at some of them. So one of the key ones will be the growth in microservices. So this is taking that step back, and rather than having some kind of an application that is delivering many services, what we're saying is we want to focus on specific functions or tasks. And what this does is this removes dependencies from each of these tasks, these services that are being delivered. So this allows different teams to step forward and build out these functions without having dependencies on each other. And due to the fact that this is driven, by nature, this is asynchronous because you're going to have lots of issues if you're trying to synchronously join these things. By that nature, they are going to be event driven. And also another driver of this is that synchronous processes can fail. And how are you going to mitigate for that? And again, stepping forward with this event-driven idea, these asynchronous services, you are starting to move away from that. Another big benefit of having these event-driven architectures, it allows us to start making real-time and just-in-time decisions. So, for example, historically you would have had some kind of data, either a cache of data you've collected, some batch process, and you'd have made some predictions off of the back of that. Now, what event-driven architectures allow us to do is to not only take that data and the predictions we've made off of the back of that, but we can now incorporate live events, state changes as they happen. And that allows us to now make real-time decisions. So something happens that wasn't expected, we can do something about it. So we can either make new projections, or we can make some kind of just-in-time decision to avert some issue that may happen. And last but not least, we've kind of touched on this when we talked about growth in microservice, this idea of being able to decouple concerns. So maybe you've got a couple of applications, you've got app A and you've got app B. So rather than having some kind of point-to-point integration with them where they're reasonably tightly coupled, so you have an impact that if you need to make changes to app A, that means you've also got to now make changes to app B. By being able to split these components apart, if you make changes to app A, app B doesn't need to know about that. There are things you can do, that kind of bridge in the gap, which this sort of event-driven architecture allows you to do to try and minimize the impact. In fact, app B doesn't need to know that app A has changed. Okay, so we've talked a little bit about that, and a big opportunity that arises in event-driven architectures, basically getting this information coming in, is this idea of being able to use the Internet of Things. So these are devices, typically, you can see them everywhere, and what they tend to do is they tend to give you some kind of state change or conditional information. So for example, we've got a picture here of a wind speed device. So that's going to be able to give us information about wind speed. So Older devices tend to be REST-based, so you need to poll them for some information. They'll send a response back. Newer devices will send out state changes to you. They tend to be location-centric as well. So the information you're getting will be wind speed for a specific location. And you tend to also get domain-specific information. So in this example here, the domain is wind speed. That's all you're going to know about it from that device. If we look at other popular IoT devices, so things such as smart light bulb, a smart light bulb is only ever going to give you information about what brightness it's currently at. Has the motion sensor been recently set off for the specific location it's in? If we're thinking about a smartwatch is going to give you information about the wearer, so what's their current heart rate, accelerometry data, as well as things such as maybe oxygen utilization, depending on the device. So it's very, very domain specific to what that device is measuring. But where it starts to get really exciting, when we start bringing everything together. So let's start bringing lots of different devices in. So they're all measuring different things. We're bringing them into an event-driven architecture. So the idea is that as new events come forward, we can act on that information. And then we also bring in domain data as well. So we're going to have domain data, so historical data about those things. We're going to have other data sources that are going to help augment with this. We're also going to have business domain knowledge. So we're going to have domain knowledge experts coming in. And then we start bringing all of these different elements together. What we start to do is get an overview of the bigger picture of what's going on. So let's pick a simple example. So let's think about, for example, some sort of logistics. So we have a vehicle. That vehicle is going to have some kind of telemetry device on it. And what we start to do is we get information about the vehicle's current location and direction. So what direction they're going in. Brilliant. We can now bring in some business domain knowledge. And then we know, well, actually, based on time and what location information we're getting and their direction of travel, we can now make predictions about what current speed they're currently moving in. We can build in some more information. So we are going to have information such as maps, so what the roads look like, what the layouts are, what the junctions are. So we can now start to build out a bigger picture where we go, well, okay, this vehicle is traveling on a certain route. We can bring in other device information. So there's going to be information such as traffic at a certain point of road. So you're going to have devices to tell you how congested a road is. So we're going to have loads of these points across different parts of a road. We're also, let's bring in weather as well. We're going to have devices that are telling us about the weather. So levels of precipitation, is it about to rain within the next 20 minutes? So we're bringing all of these elements in together. And what we do is we start to paint a picture of what the current traffic situation is, what the vehicle is going to be experiencing. We can predict, is the vehicle likely to be slowing down now because congestion is growing? Is there going to be more traffic because it's about to rain, so everyone's going to be slowing down? So we can now start to make predictions about, what speed is that vehicle likely to take? When are they likely to arrive? We can then take this further and we can start to think about making just-in-time decisions. So this picture of the current route that this vehicle is taking, there's going to be slowdown. We can now start to have a look at, well, what other routes can we take? Because we have that knowledge already, and we've got these streaming events to tell us what the current situation is. So we can bring all of these things together, and we can now start to paint a picture as to, do we want to suggest a new route? And bringing all of these elements together, we start to have this fantastic situation of where we can do things such as create new data products, and we can monetize them. So in this example here, where we've brought everything together, we can now start to think about things such as we can offer a sat-nav system. So we can offer a product which will be able to suggest a route for you. We can make it more intelligent, where it will dynamically suggest new routes to you based on traffic and weather and other elements. And other services we can offer too. So if we are a logistics company, as well as having all of that rerouting information, maybe a product we can sell is a very accurate estimated time of arrival for a package. So we can start bringing all of these different elements together. So IoT devices, event-driven architectures, the domain knowledge that we have, business intelligence, bring all of these things together to do really exciting things. So that's brilliant. But there are a number of challenges we need to think about when we start bringing these devices in and we want to incorporate them into our event-driven architecture. So there's going to be a number of challenges, and these include things such as device management. So you can think about certain domains and you are likely looking at many, many devices, potentially thousands of different devices. And that's not unusual if you think about, for example, a logistics deployment. And you need to think about what devices are available, what firmware versions they're on, how they're being used. Are they being used? Are they working? Are they functional? Are they available? So how do you get this oversight across all of these devices that are happening? The next one is security. So a device should not have to be worrying about how it's being connected to. So maybe there is some level of some sort of thin layer of security, but how do you ensure that the parties that are accessing the device have the right to be able to access it? And an extension of this is, how do you protect that device? So how do you protect it from accidental many requests going into more malicious attacks? Another situation as well to consider as well is the event management component itself and compatibility. So as we touched on earlier, some older devices maybe are just REST devices. So they don't have this event-driven element, whereas newer ones do. And it's not just about the event-driven component. There are different types of protocols available. So how are we going to manage between all of those? And the client that wants that information may not necessarily want to be dealing with streaming data. So how do we manage all of these different elements together? And another one to consider as well is scaling. So how do we manage scaling? So we may have a situation where you've got hundreds of devices that want to be able to connect to, hundreds of clients that want to connect to that client, to connect to that device, my apologies. How do we manage that? What we don't want is 100 clients who are potentially looking for the same information, so the same state of that device at a current point in time, to be connecting to that client. We don't want those point-to-point integrations. So how do we manage that scaling piece? So a way we can handle this quite elegantly is bringing in API management. And this is something that we can fit in to managing our devices, as well as fitting into an event-driven architecture. So very quickly, a brief overview of what API management is. It is a set of processes and tools that will enable you to effectively design, develop, deploy, and maintain your APIs. So much like Alim's talk earlier about thinking about API first, something like API management can help you fit that process in across your entire organization when you're thinking about the many different kinds of APIs that you're going to be using. And in general, how API management helps do this is through a number of elements. So one is security. You are able to define how you want your authorization, authentication to look like when you are connecting to your APIs. Also, you will commonly deploy your APIs into a gateway. So effectively what you're doing, you have a proxy of your API in the gateway, and then your actual API sitting on the system that it lives on. And like that, anybody accessing your API doesn't need to know about where your API actually resides. All of their communications are with the gateway itself. You can now start to think about protection too. So what we can do here is, as well as managing who has the rights to access an API or your device, we can also start to think about how do we manage inbound traffic. So for example, we can manage lots of different requests coming in from many clients through throttling. We can also manage how often a single client can access the API through rate limiting. And that's a way that we can not only protect any back-end systems, but we can also manage any kind of subscription packages that we have based on what kind of client you are connecting in. Performance is another one. So as an example, we can do things such as caching. So if there already has been a recent request to an API and that data is still fresh, there is no point to serve that request all the way through to the back-end systems. The gateway can just send back a cache, and then when that cache is expired, then we can go and get a fresh request. And then this element around documentation and governance. So being able to show what APIs are available in a central place, so in a portal of some description, allowing developers to understand what's available, so what APIs are available. They can look at the documentation, And we can do this governance piece as well. So not only can we be monitoring what kind of versions of APIs are available, who's accessing what versions have been deprecated and so forth, but what you can also do with API management is some level of data transformation. So if you have a governance policy about what an API should look like when it's being called, we can manage that. And that doesn't have to be exactly the same as what the actual backend API or device API is being called. So that's something we can do around that, and all of the other good governance stuff as well, such as access and so forth. And another element that's really useful is the monitoring and logging aspect. So what we can do is we can monitor how APIs are being called within the gateway, within the platform. We can see which ones are being used and which ones aren't. So if they're not being used, we can think about getting rid of them. We can also see if there are problems. So we can be checking to see whether an API is responding or not. We can be logging the activity so we can understand and diagnose if there are any issues, and we can build alerting off of the back of that. So if there is a problem, so if an API is being requested more times than we would expect, or some kind of strange things happening with authentication, that kind of thing, we can set up alerts and be triggered so that we can act accordingly. So we've talked about some general benefits of API management, and lots of those apply to IoT and event-driven architectures. But another thing we can do as well is look at some more specific things around this scope, especially when we're looking at devices and bringing them in. So the first one is this separation of concerns. So we touched on this earlier, and just being able to split out those point-to-point connections. If we need to make changes to device, let's say we add in a new device, we replace an old device, we've done a firmware update, any kind of maintenance around that thing, any clients that are calling in doesn't need to know about that. So that's something we can do. We can do device polling. So this is where we can poll the device and just make sure to see that they're okay. Are they still working? And on the flip side of that, there are methods we can do that if we have got devices that require some kind of request to be able to send back a response, we can set up polling to be able to do that so that any downstream systems can operate. Devices API. So again, what we can do is we can wrap around our device or any other event-based API that we've got. We can wrap that around and serve it up as an API in its own right. So this is where we can do any kind of data transformation on this as well. So if we need to change any headers or the request bodies or the response bodies and headers, we can do all of those changes in flight within the gateway as required by the client or the API that's serving up that request. And we can mix protocols and do protocol mediation. So this is where, depending on whether you're the client making the call or you're the API service, if we need to do some kind of mediation and mixing up the protocols are available, this is something that can be done. So we're going to look into a couple of scenarios. So before I do that, I just want to give you a quick look at Gravitee, which is an open source API management platform, just because we're going to be touching on these different points. So very quickly, we've got some key elements here. We've got the gateway element. So this is where your API proxies would be deployed. And in there as well, this is where we would deploy any policies. So anything around security, rate limiting, improving performance, any kind of data transformation, all of that lives in the gateway. And this is where all of your clients are going to be calling. And obviously on the other side, these are your device APIs, any other APIs you've got in the application. Then we've got the console. So this is the management console. So this is a web interface, web-based user interface where your API publishers, your admins, this is where they come in. And this is a low-code place where they can go off and define what the APIs look like. They can import any specifications like a Swagger specification, Open API, that kind of thing. They can sort of get the documentation created and all of that good stuff and define all of the various policies you want. So this is what they'll do. And then that gets deployed into the gateway. And last but not least, we've got this developer portal. So this is where developers who are looking to build out an application, they can come in, they can have a look at the catalog, see what APIs are available, look at the published documentation, they can try it. And here they can also subscribe to the API. So this is where they can subscribe and, based on, what subscriptions are to use. This is going to define what the authentication flows look like. And not last but not least, there is an API to manage all of these platforms. So if you want to use an API rather than the web interfaces, this is how you can use that to talk to all of these elements. So moving into our first scenario. So here we have got devices that API. So we're going to come into the streaming bit in a second. I just want to paint the scene. So something I'd like to point out very quickly. This is not an example of how you would do this. I'm just trying to use familiar concepts to walk through the different elements. So please don't be going off and building a weather app based on the back of this. So just very quickly, let's talk about, we've got a client here and the client wants to make a request to get some temperature data. So what's going to happen in this flow is they are going to go through these policies. So the first thing to do is to check whether they've got to sign in. So have they got the authorization? So they will do that sign in. The next bit's going to be the cache. So has somebody recently already called the temperature API? If they have, then you'll get a cache. If that cache needs to be refreshed, then we'll continue on to the next bit. The next bit is going to be the throttling aspect. So have we got lots of clients making the same request to the API? We're going to check those limits. And then last but not least, we're going to do the rate limiting. So for example, let's say the client's only allowed to make 4 calls per minute. So if they've made more than 4, then they're going to be rate limited. And if they're within the rate limit, then that call gets passed on, and then a proxy is going to call the API. In this example here, we're going to assume we've got some legacy devices here. So these are all REST-based. So a REST call will be made to our temperature device here. That's going to be sent back, and that's going to be sent back to the client. And then just very quickly as an example here, you're going to have a consumer, and if the consumer wanted to understand about the temperature API, they could look at the documentation, and they could also subscribe. Same with the API owner. So this is where they would be defining what the API flows look like, bringing that in, importing the open API specification in his example here, publish the documentation, all of that good stuff. And then they can monitor how the APIs are being used. So let's move into the next scenario. And again, this is just an example. This is not how you would necessarily go about doing this. This is just to use some context around familiar themes about how we'd go around this. And in this example here, we've got some changes. So we can assume that the policies we mentioned previously are still there. We're just adding some more in. And the things that have changed now is we've brought in a new device. So this is our flood alert device. So this is something that when a certain condition happens, i.e. the water level raises to a certain level, it's going to ping out an event, and we're going to, so I'm using MQTT protocol here. So that's quite common with IoT devices. So that's going to ping out an event to the broker. And what we've got here is we've got the service management ecosystem plugin. So that sits in the gateway. And this is what's going to be managing these events in our architecture. So we've got a number of things happening here. So in this example here, we can set up services where we can set up a process where for these devices here, we can get them pinged periodically. So they need a REST request, so the response comes back. And then what we can do is then redivert these using dynamic routing and HTTP callout. We can reroute them into a relevant Kafka topic. And the client here, maybe they want REST requests. So the client could be something where, it's an app on your phone. So it sends out a request every 15 minutes to say, give me the weather, here's my location based on, again, the device's location. Or maybe this is another process, external process, where we're selling this data product where somebody wants to have real-time changes in events in data because they've got some, let's say, rerouting for logistics. So you've got these events going on. And we can do a number of interesting things with this. So we can do data mashups because the client would be requesting weather update rather than having a weather update rather than having asking for each of these individual things. So we can do some kind of a data mashup, bringing these APIs together. Or maybe we're going to make a call to the Kafka. Now, bearing in mind as well that what we're getting back from these devices will be REST responses. We can use things as transform header and transform query parameters to convert those to create a topic. And we create this message with a topic that we can then push into our Kafka broker. So we've got all these different elements to bring together. So we've got all of these examples here of the data transformation. We've got the event management. So all of these really useful things that we can bring together in an event-driven architecture where we can manage different protocols as well as data transformation to fit all of these things in together. So very quickly, as we are to time, what's next? So if this has piqued your interest and you're interested in finding out more, my colleague Dorian will be doing a workshop following the break. So do check that out and do have a go. So you can download and have a play with the API management tool. So do go have a play. If you've got any questions, feel free to reach out to me. And last but not least, if you are using the product and you've got some questions, if you'd like to discuss any ideas or give feedback, please do. You can reach out to us on the community forum. So that's community.gravitee.io. So thank you very much.
Thank you very much, Lou. That was very, very detailed, very interesting. Just a quick question to that, basically. How long has this been possible? Because I tried to do this 2.5 years ago, and it just wasn't possible, right? So I had an elevator that was streaming data about, okay, direction and speed and everything, and I could not get that, properly exposed as an API. So how long has it been there?
So that's a great question, and I couldn't give you a specific answer about that, but I think in general, some sort of event-driven architecture has always been around. We've always called it something different. So it's always been either we've been using like enterprise service buses, or obviously we've got Kafka messages around. I think the interesting thing here is what do we do with devices? And I think commonly what has been these point-to-point integrations. Large organizations, so like we're talking big enterprise organizations, will have been heavily leaning on buses for this, and maybe they've got models and things around this. So to some extent, and I really long answer, it kind of has existed, but I think it's getting better as sort of there's an appreciation for the value of this. So I can't give you specific detail, but specific answer to that. But
I think the difference is now that we're able to sort of bring the developer experience in there into the dev pool and onboard the developers without having to have a project for 6 months in the background. So that's great. Hey, thank you so much for your presentation, and hope to see you again sometime.
Brilliant. Thank you very much.